Number 2 here, we're asked to solve. So there are multiple ways to do this, but remember, this is already linear. It already has a degree 1. So we could solve it like normal. Minus 3 to both sides. This cancels, leaving you with a 6x is equal to negative 3. Divide by 6 to both sides. This cancels, leaving you with an x is equal to a negative 1/2. Okay, all right, that works. All right, or you can you could pull out the GCF. So if you pull out the GCF of 3, this becomes 2x plus 1 is equal to 0. Right? So the 3 here, this is referred as to the GCF. Right? Now we set each term equal to 0. 3 is equal to 0, and 2x plus 1 is equal to 0. This doesn't make sense. It doesn't equal to 0. 3 cannot be equal to 0. Here we can solve like normal. Minus 1 to both sides, leaving you with a 2x is equal to negative 1. Divide by 2, divide by 2. This cancels, leaving you with x is equal to negative 1/2. Notice, we get the same answer, even if we factor or not. Okay, because this is already a linear term. Okay, for B, here, this is equal to 20x. So we have to get rid of the 20x somehow. We want to make it equal to 0. So we're going to subtract 20x to both sides. Okay, the x's are like terms, so that becomes 35x is equal to 0. Bring down that 10x squared plus. There's a GCF here. So the GCF of 10x squared plus 35x, you can find the GCF. I know the GCF is 5x. Let's see what is left. 2x plus 7 is equal to 0. So there are two solutions here. We have the 5x is equal to 0 part. That is the first term. And then the 2x plus 7 is equal to 0. That's the second term equaling to 0. Here we divide by 5 to both sides. Okay, that cancels. 0 over 5 is just 0, so x is equal to 0 as the first solution. The second solution is based on this equation. 2x plus 7 is equal to 0. Minus 7 to both sides. The 7's on the left cancels. 2x is equal to negative 7. Divide by 2, divide by 2. This does cancel, leaving you with x is equal to negative 7 over 2. That's how we solve. Okay? C. We want this equal to 0. So we're going to add x squared to both sides, and these two are now like terms. This becomes 2x squared plus 16x plus 24. We bring down those terms. It now equals to 0. I notice there is a GCF, and the GCF here is 2. If I pull out 2 from each term, that leaves me with an x squared plus 8x plus 12. Okay? I can now try to factor the inside here. So I'm trying to find two numbers that multiply to make 12. That adds up to make this 8. Okay. And 112, let's see, 2, 6. Oh, that works. 2, 6 does work. I forgot to make this adding. Okay. 2, 6, 2, 6. That works. Now I want to divide by this 1 here. So divide by 1x, 1x. So our factors here are going to be x plus 2 and an x plus 6. And we set this equal to 0. But don't forget that we have to bring down the GCF of that too. Now we have 3 terms. We have to set each term equal to 0. 2 is equal to 0. X plus 2 is equal to 0. And x plus 6 is equal to 0. Now we solve it individually. 2 can never be equal to 0, so this makes no sense. For x plus 2 equals to 0, we subtract 2 to both sides. This cancels, leaving you with x is equal to negative 2. The x plus 6 equal to 0, we subtract 6 to both sides so that the 6's cancels, leaving you with x is equal to negative 6. Okay, so this probably required you to pull out the GCF and to factor it, and then to solve. The next one. Okay, this one's a little bit more complicated because there's more terms, but you essentially do the same thing. To get rid of a negative 2x, you add 2x to both sides. Then you have a 7x squared here, so we're going to subtract 7x to both sides. Okay. Here this cancels. On the right hand side does cancel. We have a negative 14x plus 2x. That becomes a negative 12x. And then we have negative 2x squared and a negative 7x squared. That becomes a negative 9x squared. Then bring down the 3x cubed. That equals to 0. Is there a GCF? Yes. If you just break this down, finding the GCF, you know that the GCF here is going to be 3x. Leaving you here with a 2x minus 3x minus 4. Okay, let me double check. 3x. No, this should be a 1, right? Okay. X squared. Okay, you pull that out. 3x cubed becomes x squared, okay? And you pull out a 3, that becomes correct, and that becomes x. Perfect. So that equals to 0. Let's see if we can factor this. We're going to find two numbers that multiply to make negative 4. That adds to this middle number of 3. That looks like I think it's 1 and 4. Okay, and I think the negative is going to be on the 4. Yep, now we divide by the 1x here. So divide by 1x. Now you get the factors of x plus 1 and then x minus 4 equaling to 0. Don't forget to bring down that GCF of 3x. Okay. Now you set each term equal to 0. 3x is equal to 0. X plus 1 equals to 0. And x minus 4 is equal to 0. Divide 3 to both sides because we're trying to get x alone. 0 divided by 3 is just 0. So the first solution is x equals to 0. X plus 1 equal to 0. We minus 1 on both sides. That cancels. We get x is equal to negative 1. We have x minus 4 equals to 0. We add 4 to both sides. This does cancel, leaving you with x equal to 4. In this solution, in this problem, we actually have 3 solutions. The reason why is because if you look at the original problem, the highest degree is a 3. It's a cubed. So that's why we have 3 solutions here. Everything else, take a look. Notice that the second and third, B and C, the highest degree was 2. It was a quadratic, therefore there are 2 solutions. A was a linear term. There was only 1x. That's why there's only 1 solution. Okay, the highest degree tells you how many solutions there are to the polynomial.